quicksort algorithm. In the last class, we were studying about insertion, selection, and bubble sort. We have already studied merge sort and sort also. Actually, these sorting methods have quadratic worst case performance. What do you mean by quadratic? Tell me. Quadratic means the higher order term will be, bigger notation will be n square. The first, is there any first comparison based algorithm? That's our question. That means, is there any sorting algorithm with order of n log n? So there are some methods. Actually, this insertion, selection, and bubble sort have quadratic worst case performance. That is order of n square. And some other sorting methods are there, like merge sort and quicksort. These sorting methods have complexity order of n log n. We will study quicksort now. Algorithm. Okay. Given an array of n elements, for example, element integers. If they only contain one element, then we can return directly. Actually, array of n element means there is only one element, means we can return directly. No need to sort it. Else, if the array contains more than one element, then we have to sort it. So this is the case. If the array contains one element, we have to choose one element as a pivot element. Then partition the element into two subarrays. Like merge sort, we are going to partition the array into based on this pivot value. Pivot, it is a one element. You can choose one element as pivot element. So partition is based on these condition. Elements less than or equal to pivot element. These elements will fall under one array, one subarray. And elements greater than pivot element is stored in another subarray. So we are having two subarrays. We will divide the elements into two subarrays. In the first subarray contains the elements less than or equal to pivot element. And in another subarray, we are having elements greater than this pivot element. So quicksort, after that we will recursively call this quicksort. Then return the result. This is our procedure. First of all, we will choose one pivot element. Then we will divide the array into two arrays. One array contains elements less than or equal to pivot element. And another array contains elements greater than pivot element. Then we will recursively call this quicksort. I think we will. Okay, let me explain the algorithm. After that, I will explain. Okay, you wrote this algorithm. Okay. So first of all, we have to set a low value and high value. So we are using two pointers. This is very important. So first index 0 is set as low and the last index is set as high. That is n minus 1. Then if low is less than high, then we will partition. We have to find the middle element. Mid equal to partition low, high. Then we will apply. So we got the mid value. So we have to apply this quicksort on the first array. That is low to mid minus 1. Then after that, we have to apply quicksort on mid plus 1, high. Then exit. So we are having an array. Is it visible? Okay. So 50, 25, 8, 3, 70. Okay. Suppose these are the numbers and we are stored in this array. So this is at 0, 1, 2, 3, 4. Quicksort. So first of all, this is low. And this one is high. So we need to partition this one into two sets. So for this one, actually we have to, what is the first step? Low is 0 and high is n minus 1. These are the steps. What is the next step? Next we have to find, we have to check whether if low less than high. If low less than high, if this is the condition, if this condition is true, what is the value of low now? Low is 0. And what is the value of high now? What is the value of high? Look at this picture. What is the value of high? 4. Yes, high is 4. Index value. So 0 less than 4. So this condition is true. What is the next step? We have to find the middle value. Actually, it is not middle value. I will explain it later. For the time being, consider it as middle value. So we are passing this low value and high value to this partition. I will study this partition later. So we will find a middle value. So we got some middle value. It's not actually middle value. It's just a variable. Suppose the middle value is this one. This is middle. Okay, then we have to apply quicksort on this region as well as quicksort on this region. So we are having two sets. This is the first set and this one is the second subarray. So actually in the quicksort and in this quicksort, here the parameters are low and high. We are passing low value and high value to this function. And these are the steps. Okay, so after finding the mid value, we have to apply quicksort on the first set. What is the low value of the first set? So again, we have to apply quicksort. What is the low value? So we have to set the parameters of quicksort. Here the parameters are low and high. So in the first set, this is the first set, low to mid. Okay, how will you write the quicksort of first case? Tell me. It's not the element, actually it is the location, okay? Suppose this 2 is the mid value. Suppose mid value equal to 2. So I already told that we have to apply quicksort on the first subset, that is in this green area. How will you call this green area? What are the parameters of quicksort? Tell me, what is the low value? Actually, the parameters of quicksort are low index and high index. What is the low index of this subarray? Upper value is 1. 1 means it is 1 less than the mid value. So we can write it as quicksort of low and mid minus 1. Okay. Okay, what about the next case? Bijin, tell me. So now we have to apply quicksort on the next set. This set. This is the set. Okay. Okay, tell me the arguments. Quicksort on. This is the next set. Actually, we are assuming that the middle element will be in the correct order. So if the middle element is in correct order, the second set consists of 3 and 4. How will you write the parameters? What is the low value here? Bijin, low value. What is low?
3.
Yes, 3. 3 means? From yes.
Mid plus 1,
mid
2.
Yes, that's okay. Mid plus 1. Mid plus 1 is the low value. What is the high value here?
4 and 4.
High value is 4. That is 4 means where 4 is stored?
High.
Yes, that's correct. So first of all, we will find the middle value and we are assuming that after partition, the middle value will be in the correct order. So we have to partition the other elements into 2. That is elements which are less than this 8. Elements which are less than this 8 will fall in the first subset and elements greater than 8 will fall in the second subset. So we will apply quicksort on this first subset first. So here the low value is low. So here the high value means it will be mid minus 1. And in the second subset, the low value will be mid plus 1 and high value will be high only. Is it clear? Is it okay? So first step is we have to set the low value as j and write these steps high value as j. And the lowest value of the array is set as x. So this one is selected as pivot element. X is a lower. That is the first element is selected as pivot element. This x means pivot element. A low means it is the first element. Initially low is first element only. Okay, then we will check this I is less than, low is just less than or equal to high. This must be the condition. Then we have to check this condition, these two conditions. A of I less than or equal to j. I will explain the algorithm later. I think I can explain the example first. Otherwise, you won't understand it. So back to the example. So we can consider the same numbers. 50, can you read the numbers? 50, 25, 8370. And the first step of this algorithm is I equal to low. First step, I equal to low and j equal to high and x equal to a of low. So this one is I. This is I and this is j. And x means a of low. This is the array A. A of low. What is the value of low now? Lapos. Yes, 0. What is the value of high? Value of high. High is pointing to the upper range. Value is, so x equal to a of low. A of low means what is the value? Low means value is 0. A of 0 value is? A of 0 value is 50. So x equal to 50. So this one is our pivot element. This is our pivot element. Okay. This is our pivot element. Then our next step is, we have to check whether this I is less than or equal to j. So next step is, repeat while I less than or equal to j. Is this condition true? Is I is less than or equal to j? Yes, I is less than or equal to j. That condition is correct. And we have to check one more condition. I is, sorry. First of all, we had checked I is less than or equal to j. If I is less than or equal to j, then we have to check A of I is less than or equal to x. A of I less than or equal to x. And at the same time, we have to check I is less than n. So if I is less than, this condition is true. I is less than j. Here value of I is 0 and value of j is 4. So I is less than 4. That condition is true. Then we have to check A of I less than x and I is less than j. If this is the case, then we have to increment the value of I. So next step is, if both these conditions are true, then we have to increment the value of I. Now again back to our example. A of I. What is A of I? Tell me, what is the value of I now? Tell me, what is the value of I? Look at the screen and tell me, what is the value of I? It's already written there.
0.
I is already 0. We didn't increment the value of I. So I is 0. I is 0. And j is 4. Okay. X equal to 50. What is A of I? A of 0. What is A of 0?
50.
50. So our condition is 50 less than or equal to 50. Is this condition true?
Equal.
Condition is true because equal to is there. 50 equal to 50. Condition is true. And we have to check I less than n. What is the value of I? I is 0. Less than. What is the value of n? Value of n. N means total number. What is the total number? What is n? What is n? 5. Yes. So 50 equal to 50 and 0 less than 5. So this condition is true. So we have to increment the I value. So if this is the case, this condition is true. So we have to increment the I value. So we are incrementing I value. Now I is pointing to 25 and I equal to 1 now. There is no change in the value of j. Again, we have to repeat this while loop. What is the value of A of I? A of I means A of 1. What is the value of A of 1?
25.
25. So next condition is while loop is repeated. A of 1 is 25 less than or equal to, what is the value of x now?
50.
Is there any change in the x? Is there any change in x? X means what is x? X is pivot value. Pivot value won't change. Pivot value is 50 itself. So this is 50. Okay. And I, what is the value of I now? What is the value of I? What is the value of I? Tell me.
1.
1. 1 less than 5. So both conditions are true. 25 less than or equal to 50 and 1 less than 5. So what we have to do?
Increment.
increment I. So again we have to increment I. So now I becomes 2. I becomes 2 and there is no change in the j value. Is there any change in x value?
ಇಲ್ಲ
Is there any change in x value?
ಚೇಂಜ್ ಇಲ್ಲ
Change illa. Okay. So again we have to check the condition. A of I. What is A of I? Value of I is 2. So A of 2. A of 2 less than or equal to x. X is 50 and 2 less than 5. Okay. So what is A of 2? What is A of 2? A of 2?
8
8. So we can write 8 less than or equal to 50 and 2 less than 5. Is this condition true?
ಟ್ರೂ
Yes, this condition is also true. So what we have to do?
increment I value
Increment I value. Okay, similarly we have to do this these steps. Then until these two conditions are true. So next step is once either of these condition is false, we can exit from this while loop. Next we have to do one more step. We have to check the J index. That is while A of J, here it is less than or equal to, here it is greater than x, and J here the less than n, here it is, can you tell me the condition J greater than or equal to 0? If this is the case, we have to decrement the value of J. So once we exit from the while loop, we have to check the value of J. So after that, I will explain the algorithm. After that, we will do the example. So first we will do this while loop. After that, we will perform this while loop. Then next step is we have to check if J less than, I less than J. If I is less than J, then we have to swap A of I and A of J. That means A of I and A of J are exchanged. Or you can write it as, write like this also, swap A of I and A of J. If this is not the case, if I is greater than J, then we can swap, else we can swap A of J and A of low. Finally, you can return J. So this is our algorithm. Example. Okay, so we are given some numbers 40, 20, 10, 80, 60, 50, 70, 30, and 100. Now we are choosing the first element 40 as a pivot element. That is, we are choosing A of low. A of low means here it is 40. So there are a number of ways to pick the pivot element. In this example, we will use the first element in the array as the pivot element. So we are pointing low to the 0 and high to n minus 1. That is the last element. So low is pointing to the first element and our step is to maybe net problem. Okay, actually pivot element is 40 and low is pointing to the 0th element and high is pointing to the last element. Then we are applying quicksort on low to high element. If low is less than high, low means what is the value of low? Yes, low. Yes, 0. I can't hear. Okay, low is 0 and what is the value of high? 0, 1, 2, 3, 4, 5, 6, 7, 8. Value of high is 8. So 0 is less than 8. So we can proceed to the next step. What is the next step? We have to find a mid value. Mid equal to partition of low and high. So we will call the mid partition function. So partitioning array. Next our step is to given a pivot, partition the elements of the array such that the resulting array consists of one subarray that contains elements greater than or equal to pivot element. Another subarray that contains elements less than pivot element. So actually partition is based on this pivot element. After placing the pivot element in the right place, we will get two arrays. Left array and the right array. Left array means the elements will be always less than or equal to pivot element. Right array means the elements will be greater. The subarrays are stored in the original data array. Partitioning loops through swapping elements below or above pivot element. Which is our pivot element? First element is the pivot element. That is 40. 40 is the pivot element. And we had said in the first step of the algorithm, we had wrote that the low value is saved in I and high value is saved in J. That means lower value is J and higher value is, lower value is I and higher value is J. So pivot element is 40. Now our first step. While A of I less than or equal to pivot. What is A of I now? I means 0, 40. So 40 less than or equal to pivot. Is it correct? 40 less than or equal to 40. Correct. So then I plus plus. So I plus plus means I will be incremented. So now I will be pointing to 1. It is shown in figure. So I will be pointing to 1 and J will be pointing. There is no change in the position of J. J will be pointing to 8 itself. Then again, so in the we had checked the first case and now we have to repeat the loop. Again, I is pointing to 1. So what about A of I? What is the value of I? Value of I. Value of I is 1 and A of 1 is
20.
20. 20 less than or equal to pivot. Is it correct?
Correct.
Correct. So we have to increment the value of I. So I will be pointing to next element, that is 10. Index 2. Again, we have to repeat the loop. That means while A of I is pointing to 2, and what is A of 2?
10.
10. So 10 less than or equal to pivot element. What is pivot? Pivot
40.
element 40. There is no change in the pivot element. So 10 less than or equal to 40. Is it correct? Yes. So again, we have to increment the value of I. So I will be pointing to 3. Again, we have to repeat the step. I is 3 and the A of 3 is, what is A of 3?
80.
80 less than or equal to pivot element. Is it correct? Here. So the next step is, next we will move to the next while loop. So we can, we had start from the left and move to the right. Now we are going to start from right position, then move to the left. So what is A of I? A of I is, what is, A of J. We are starting from the right position. What is A of J? What is the value of J?
J8.
What is the value of J?
8.
J is 8. So we have to check A of J. A of J means 100. 100 greater than pivot element. Is it correct? What is pivot element?
40.
40. So this condition is correct. 100 is greater than 40. So we have to decrement the value of J. Now J is pointing to 8. After decrementing, J will be pointing to 7. J will be pointing to 7. And value of A of 7 is 30. So again, we will repeat the step. So value of A of J is 30 because A of 7 is 30. And pivot element means, what is pivot element?
40.
40. So 30 greater than 40. Is it correct? Allah. So we will stop it here. So we will stop the while loop. Then, so next step is, if I is less than J, if I is less than J, then we can swap A of I and A of J. What is the value of I now?
3.
Look at the, yes, I is pointing to 3. And what is the value of J?
7.
7. I is 3 and J is 7. That is 3 less than 7. Condition is true. 3 is less than 7. So we can swap the elements at third location and seventh location. That means in the third location we are having 80 and in the seventh location we are having 30. So we can swap 80 and 30. So elements are changed. You have to remember that no need to change the location of I and J. We cannot change the location of I and J, but we can exchange the elements. Just exchange the elements. Don't exchange the I and J pointers. Okay. So our next step is, while I is less than or equal to J, then we have to go to step 1. So what is the value of I now? I is 3 and J is 7. So again we can repeat the first step. While A of I less than or equal to pivot element. So what is pivot element now?
40.
What is the pivot element?
40.
Pivot element? 40. 40 itself. So what is A of I?
30. Exchange it. 30.
Yes, after exchanging, I is pointing to 3 itself. So element is 30. So 30 less than or equal to 40. Condition is correct. So we can increment the value of I. So I will be pointing to 40, sorry, fourth position, and the element is 60. So again, 60 less than or equal to pivot element. Is it correct?
അല്ല correct അല്ല.
Allah, correct Allah. So we can stop it here. Again, we will move from the right position. Right position means A of j greater than pivot element. What is A of j? A of j, j is pointing to 80 and 80 greater than pivot element. Is it correct?
Correct.
Is it correct?
Correct.
Correct. So we can decrement j value. Okay. So again we have to check here. J is pointing to this location. There is one mistake. Actually, j is pointing to 7. Then we will check 7 greater than pivot element. Is it correct?
അല്ല. correct
Allah.
അല്ല.
So correct Allah. So we can and then we have to check this step. If I less than j, value of I is 4 and value of j is 6. So condition is correct. 4 is less than 6. So condition is correct. So we can swap A of I and A of j. A of I is 60 and A of j is 7. So we can swap these two numbers. So after swapping, you will get like this. Don't change I and j. Okay. So now it is pointing to 40 and 70. So again, I is less than j. So I is less than j means you can swap A of I and A of j. After swapping, again we will check I is less than j. Again, this condition is true. Again, we are checking. We will go to the first case. A of I less than or equal to pivot. What is A of I now?
7.
A of I. A of I. I is pointing to 60. 7 after exchanging. 7 and 60s are exchanged. So
A of I 7.
exchanging it will be 7. So 7 less than or equal to pivot element. Is it correct?
Correct.
Correct. So we can increment the value of I. I is incremented. Then again we will check 50 less than or equal to pivot. Is it correct?
അല്ല correct അല്ല.
No. So we will stop it here and we will check from the right position. That is again j is decremented. So we will reach j here. So 50 j, I and j will be pointing to 50.
J
Then
60
again,
അല്ലായിരുന്നു നേരത്തെ.
yes, this process is repeated.